Hi everyone, welcome back to our new video of the series where we are discussing about design and analysis of algorithm. In our introductory video, we have discussed that efficiency of algorithm can be calculated in two ways. One in terms of space complexity and other in terms of time complexity. In our previous video, we have concluded what is space complexity, how to calculate space complexity and general rules of the space complexity, right? There we have discussed that space complexity is nothing but the amount of space required to execute an algorithm. In a similar fashion, what time complexity means is, if you I just want to in a layman terms, it's how much time algorithm will take for its own execution, right? So that is how we define time complexity, right? It indicates how much time it takes to execute an algorithm. But this this generic definition for time complexity in terms of programming languages doesn't suit fit. The reason why it doesn't suit fit is because this execution of algorithm, right? So let me just write it. So this execution of algorithm, right? I write time taken for execution. Oh, I'll just write it again. Time taken to for execution of algorithm. Now I'm saying it's very generic. The reason is this execution of algorithm may depends upon several factors. What we mean by several factors? For example, if you have a machine, right, which is have a latest configuration, and one machine which has is the oldest machine with the very basic configurations, right? So obviously you will find that on the latest machine or the latest configuration machine, this executes very fast, and on the very basic configuration it's execute little slow, right? Not even on the machines, if you see what kind of compilers they are using, right, even that also affects it, right? So there are some external factors which affects the time complexity of an algorithm or execution time of an algorithm. Okay, so let me write that factors affecting execution of algorithm. So one factor can be your machine, other can be your compilers. Also, if you see your programming language, right, it depends upon which programming language we are using, right? That also have an impact. We know that among C++, Python and Java, which one is more faster, right? So even your choice of language makes an impact on execution time. So these factor affects it, right? That's why to calculate time complexity we should understand the fundamental of independent of these factors, right? Then only we can define time complexity, right? So what that fundamental factor here is, so now we define time complexity as it is number of time a particular instruction, or I say is as basic operation is executed. This is how I define the time complexity. Now means how many times the basic operation of an algorithm is executed will give me time complexity. Are understanding? For example, if I have to give an example, right? Let's say I have some search algorithm, let's say. So what I mean by basic operations right here. So basic operation, if I have to give a definition of basic operation, what I mean by basic operation, it is the most important operation of the algorithm. That is the operation contributing the most of the total running time. I understand. For example, if I am adding two numbers, A and B, so my basic operation is this when I'm doing A plus B. So this is how the heart of the algorithm, correct? and this is how we'll be getting the time complexity. So we'll calculate how many times this a plus b has been executed, and we'll get the time complexity of that. Are you understanding? Similar way, if I take search algorithm, right, in this search algorithm, what do you think the basic operation will be? The basic operation here will be nothing but comparison, right? You're comparing your key element with all the element present in the array. So you will calculate how many times this comparison has been made, and then you will say that as a time complexity. Are you understanding? So time complexity doesn't mean that you should say in how much time the execution has done. No, because it will create a redundancy, as it depends upon several external factors which we have already discussed. So to, you know, remove that conflict of different time complexity for a same algorithm, we come to a conclusion that will count the basic operation of an algorithm, and then it will give us the time complexity. Are you understanding this? So if you want me to write the basic operation, what I mean by basic operation, though it's not a universal term or something, it's just my way of understanding things, right? So I can write that it is the most important operation of an algorithm. It's the most important operation of algorithm, that is the operation contributing the most of the total running time, or in very general term you can say the operation which is heart of the algorithm, which is heart of the algorithm, which is not a book language for sure, but to understand this will help us. Algorithm, are you understanding? So we'll see in our next video or coming video, we'll solve a lot of example, at least 10 to 20 examples, how to calculate time complexity, and then we'll realize how this basic operation help us, right? Okay, in our next video, we'll discuss about the formula like we discussed for space complexity, and then coming forward, we'll have some examples to calculate time complexity. So if you like the video, please do like, share and subscribe. Thank you.